9.3 Non-mechanical and mechanical hazards. In this element, we will be discussing the mechanical and non-mechanical hazards that can arise from any type of machinery at our workplaces and how we can apply the approach of hierarchy of control to reduce and eliminate the hazards and risk related to the non-mechanical and mechanical hazards at the workplaces. The hazards of machinery can be divided into two categories: mechanical hazards and non-mechanical hazards. Mechanical hazards are mainly from contact with or being caught by the dangerous moving parts of machine. Non-mechanical hazards are mainly from the power source or things emitted by the machine. First, we're gonna discuss the mechanical hazards in detail. The mechanical hazards of machinery are identified reference to the consequences of contact or exposure. For example, the injury causation mechanism and can be further subdivided into the following classes. The first one is crushing, in which the body is trapped between two moving parts or one moving part and a fixed object. For example, a hydraulic lift collapses, crushing a person underneath it. The second one is shearing, in which a part of the body, usually fingers, is trapped between two parts of the machine, one moving past the other with some speed. The effect is like a guillotine, shearing off the trapped body part. The third one is cutting or severing, in which contact is made with a moving sharp edge part such as blade. For example, the blade of bandsaw. Entanglement. Loose items such as clothing or hair get caught on a rotating machine part and the person is wound up onto the machine. Drawing in or trapping hazard, in which a part of a body is caught between two moving parts and drawn into the machine. For example, at in-running lifts where two counter-rotating rollers or parts meet. Impact hazard. Impact hazard, it refers to the body is struck by a powered part of a machine. This is similar to crushing, but there is no fixed structure to trap the person. The speed and weight of object does the damage. Moving towards the stabbing or puncture hazards. Stabbing or puncture hazards refer to sharp parts of the machine or other parts of material ejected from the machine which can penetrate the body. For example, swath, sieving machine needle, abrasive wheel fragments, and nail from a nail gun, etc. Friction or abrasion hazards. Friction or abrasion hazard refer to a contact is made with a fast moving surface which may be smooth, for example, touching a spin driver or rough. Friction or abrasion hazard created when contact is made with a fast moving surface which may be smooth, for example, touching a spin driver, or it can be rough. High pressure fluid injection hazard. Fluid at very high pressure is ejected from the machine and penetrates the skin. For example, hydraulic fluid escaping from a burst hydraulic hose. These all are the mechanical hazards. Now we're going to discuss the non-mechanical hazards in detail. The non-mechanical hazards of machinery are all of the other hazards that do not arise directly from contact with the dangerous moving parts. They are mainly associated with the power sources of the machine or are things that it emits. In other words, they are all the hazards that remain once the mechanical hazards have been listed. The non-mechanical hazards of machinery are electricity, noise generated by machinery, vibration generated by machinery, any type of hazardous substances involved in the operations of machinery, ionizing radiation produced by the machinery, non-ionizing radiation, and extreme temperature caused by the operation of machinery, and ergonomics requirement during the operation of the machinery, slippery falls due to the operation of the machinery, and fire and explosion hazard due to the operation of machinery. These all are the non-mechanical hazards. We have discussed these all non-mechanical hazards in previous unit of IGC2. Here we will discuss only hazardous substances and ergonomic hazards. Hazardous substances are often contained or used by machinery as an integral part of the process. For example, a metal cutting lathe uses cutting fluid to cool and lubricate the cutting bit. In other instances, hazardous substances are produced as a byproduct of operation. For example, a robot welder produces fielding fumes. Ergonomic hazard result from the interaction of the machine operator and the machine, from the posture that the operator has to adopt during machine use and the stresses it put on the body. For example, a construction worker using a concrete breaker may have to support the weight, for example 8 kg of the breaker, in order to cut a hole for a door lintel.